Okay, so efficiency is a couple ways we can look at it. Efficiency is actual mechanical advantage divided by theoretical mechanical advantage, or it's output work over input work, right?
Yeah.
Efficiency always has to be a number between what?
0 and 100.
Okay, as a percent, 0 and 100%, or as a decimal between 0 and 1, right?
Mhm.
So it can't be bigger than 1 or bigger than 100%. So you know that there's no way the output work could ever be greater than the input work, but it could be a little bit less because of friction.
So
right?
people are stupid when they say give 110%.
Right, they are. Because if you actually gave 110%, the universe would explode. It would be, yeah. It would
I'll
work.
tell
It
my
would violate conservation of
Are you sure
energy.
one?
I'll say my physicist teacher or physics teacher, what is it? Physics teacher told me I would explode, so I'm not gonna do that.
Yeah, just say no to
Okay.
doing 110%. Okay, so what is the input, is that what we're looking for? No, output work.
Force.
What's the output work?
What do you mean?
Well, what's the output work? What's done by, and if the machine weren't there, what is accomplished? You know?
2.08 times.
Right. So we're lifting a load with a weight of
Why
mg.
because it's not vertical force.
Right, because that's how far it's being lifted vertically. So that's ultimately what's being accomplished. Once we disassemble the ramp and get rid of it, what got done? This load got lifted up that far, right?
So do we do that? We
Right,
can-
so that's output work.
Do you do diagrams to fix problems or not usually?
I mean you could, but I don't think you really need to. It's, you know what it's gonna look, it's gonna be a ramp and you're just gonna be pushing the force. All it's gonna look like is this, right? There's the input force, there's the input distance, and this is gonna be the output force and the output distance, right? So the workout is gonna be 37.3
Wait, oh yeah.
times 9.8, that's the weight,
Mhm.
times
Gravity.
2.08, right? The input work is gonna equal, is gonna equal the input force, which is what we're looking for, times 4.72, right?
Why?
Because the input force equals, input means that we're doing,
Oh, we're
right?
helping, that's what the machine is doing.
That's what we're doing to the machine to get right. So we're pushing with a certain force through a distance of 4.72 meters, right? And we know that the efficiency is just the ratio of those two things, right? So really what we could do is we could say, we could make an equation out of this.
Yay.
And we could say that equals 0.623. So here's my equation.
Wait, it's divided by all?
The ratio of the output work to the input work equals efficiency.
Wow.
So all I've got to do is just solve for F.
Okay.
Okay? So I've got a little trick here, right? I could just exchange these diagonally. Right?
Yeah.
So what would I get? Well, we can figure it out. We would get the quantity 37.3 times 9.8 times 2.08 divided by the quantity 4.72 times 0.623, right? And that gives us 258.56, so 259. How many sig figs do we have here though?
3?
3. Okay, so 259.
Yep. Wow.
Let's see if that's right. What are my units going to be?
Newtons.
Boom.
Wow.
Looky there.
That was so smart. I couldn't figure that one out.
Yeah, it's not, you can, now you will. No big deal. Okay, make sense?
Yes.
Okay, let's backtrack. Number 2. Okay, so number 2. So the moral of the story on this one is that when you want to calculate the mechanical advantage of a compound machine, you just take the products of the mechanical advantages of the simple machines that build it, right? So think about what's going on here now. When we're riding a bike, we're pushing on the pedals. So the input force to the first simple machine is going to be us pushing on the pedals, right? And the output force is going to be however hard that first sprocket pulls on the chain.
How does the radius of the wheel help us?
Okay, so here's how that helps us now. We're going to calculate the theoretical mechanical advantages, and then we'll multiply by the efficiency, right? So the theoretical mechanical advantages don't have anything to do with forces. The actual mechanical advantages are how much the force is multiplied. So actual mechanical advantage for a simple machine is always output force divided by input force, right? So if the actual mechanical advantage is 3, that means the output force is going to be 3 times bigger than the input force, okay? The theoretical or ideal mechanical advantages have nothing to do with force. Those are based on, in a perfect world, what would we predict the mechanical advantage to be. Those are based only on the physical parameters of the machine. So for example, the lengths or the distances. So, and it's always going to be the opposite for those. It's always going to be input over output for those, right? Because think about a simple machine that multiplies force, like with a crowbar. I've got to push it through a large input distance to get a very small output distance, but the forces are multiplied, right? So it stands to reason then that the ideal mechanical advantage or actual mechanical advantage will always be input distance divided by output distance, or a substitute for that. Like remember in the case of a pulley system, we just count the number of ropes. But it's always going to be based on something we can look at the machine and say, okay, based on these measurements, the way it's built, is what we predict it will be. So for the first simple machine then, we want the input distance, in this case the input radius, right, divided by the output radius. Wasn't the input radius going to be the radius of the pedals, because that's what we're pushing on?
Yeah.
Okay, output radius is going to be the radius of the gear attached to the pedal. So we're going to end up getting, for our first simple machine, the theoretical mechanical advantage, let's just call it TMA1, is going to equal 191.2 millimeters divided by 66.1, right? And that's going to give us a mechanical advantage of a little, well, about roughly 3, right? Not quite 3, just slightly less than 3. So the first simple machine, the pedal attached to the gears actually multiplies the force that's being applied to the chain, okay? What about the second one, though? Let's look at the second one. Okay, the second mechanical advantage, think what's going on here. Now the chain, from the perspective of the second simple machine, the chain is being pulled across the gear, right? The sprocket. Think about a 10-speed bike. If you just look at the back wheel, that chain is being pulled by the other mechanism in the front. The chain is being pulled around that gear, right? What's the output of that? Well, it's going to turn the rear tire, okay? So the input force is going to be what's provided by the chain. The output force is going to be whatever the tire pushes on the ground with to make you go forward. Agreed? Does that make sense, though? Okay. And if you really think about that, that's the way it has to be. Because if you look at the bike, it's just one machine. You're pushing on pedals. That's the input, and the output is the bike pushes on the ground and makes you go forward.
Yeah.
Right.
With the chain.
But the chain's the middleman. Okay. In this case. So then the input distance for the second simple machine must be whatever the radius of the gear is that the chain is pulling on, right? Does that make sense? Because the chain is pulling on the gear, and that has a radius of 27.6 millimeters. if you looked at the rear tire, wouldn't it just look like this? We've got this little gear that the chain is wrapping around, right? And the chain is turning that wheel, and then attached to that is this big tire, right? That's being rotated, okay? So then we're gonna get 27.6 millimeters divided by the big radius of the tire, that's the output distance. So that's 310.85 millimeters. Well, that's a really small mechanical advantage, isn't it? That's like less than 1/10, right? So the overall mechanical advantage is just gonna be the product of those two things. That one times this one gives us what? Well, we can look on our calculator and see. So 191.2
So
divided,
those two times each other?
yes, divided by 66.1. There's the first mechanical advantage. 27.6 divided by 310.85 gives us the second mechanical advantage, and we'll just take the product of those two. So the first mechanical advantage times the second mechanical advantage gives us a pretty small mechanical advantage, 0.25 something. But isn't that the way, at least in this gear, that's the way the bike is probably designed to be, right? What does a bike do? Does it multiply force or does it multiply speed?
Speed.
Speed, yeah. Bikes are really for getting places fast. We can, you can't, if the hill gets too steep, you gotta get out and walk because you're at a mechanical disadvantage on the bike, right? But that makes sense. The mechanical advantage is less than 1 because we're sacrificing force to buy some distance or speed, right? Okay, but that's not quite our answer though, is it? Because the bike is only 94.4% efficient. So this is the theoretical mechanical advantage, but the actual mechanical advantage is gonna be only 94.4% of that, right? So then we've still gotta multiply by 0.944. Of course, you gotta make that a decimal, right? And so that's our actual mechanical advantage, less than 1/4.
Don't you have to times it by your newton?
Okay, so now here's the deal. So what's the actual amount, if that is the actual mechanical advantage, is only 0.2424, that's what we're multiplying the force by, right? So if I wanna know how much force is actually being applied to the ground when I push on the pedals with 386 newtons, Libby, what do you think I'm gonna do? This is the actual mechanical advantage. That's how much I'm actually pushing on the pedals with. How much am I getting back on the ground, do you think? So this is, remember, actual mechanical advantage is how much we're multiplying the force. Usually, for a simple machine, it'd be something like 3 or 4, right? Where the mechanical advantage is bigger than 1. So if I input 100 newtons, I'm gonna get back, if it's 3, I'll get back 300 newtons. Because I'm just multiplying by 3, right? But this time, it's less than 1, which we understand, because we're trying to get extra speed out of it. But I still do the same thing. I'm just gonna multiply the input force by the actual mechanical advantage to get the output force, right? And remember the relationship that reminds us of that is actual mechanical advantage is always output force over input force. So if I solve for output force, I just multiply both sides by input force, right? So if I multiply this number times 386, we get 93.6 to 3 decimal places. Is that how many I keep here? Looks like it, right? So 93.6, what are my units gonna be for output force? So, but what are the units for us? Newtons. Okay, so 93.6, let's try it out. Let's make sure. Oops.
I never did them.
Got it. Okay,
Woo!
about that. Okay, I got one more for you.
No, we only have 4 minutes.
That's right. This is no big deal.
Did you do 5 instead?
Which one?
5.
Sure.
Wow, yeah.
the 5 might be, yours might be different than this, cause they're a little bit
Is
random.
it long?
Is that what yours wants? Theoretical, or what's yours asked for?
No, mine wants the AMA.
Yeah.
AMA, okay. So the theoretical mechanical advantage is super easy for this. How would I find it?
Just divide the meters.
Yeah, 4.47 meters divided by 1.25 meters, right? Piece of cake. But if I wanna do actual mechanical advantage, maybe that's 4 on mine.
Yeah. Yep, that one.
Okay, so that's output force divided by input force, right? So output force is gonna be the weight, so 28.8 times G, times the output distance, which is how far it got lifted vertically, right? So all I'd have to do on this one is
That's
go,
it?
well, okay, divided by the input force. So
Okay.
then it would just be,
What's the input force again? Force.
so it's gonna be applied force times applied distance. So 305.1 newtons times 3.44 meters, right?
Mm-hmm.
So, I'm sorry, but mechanical advantage, what am I doing? I'm thinking of efficiency, right? Mechanical advantage is just forces, right? So it's just gonna be 28.8 times G, whatever the weight is that I'm lifting, divided by how much force I'm applying. So
So we
all
ignore
it's-
the distances?
So we don't even care about distances on actual mechanical advantage. It's just the ratio of output force to input force.
Wow.
So 28.8 times 9.8 divided by 305.1.
That's it?
That's it.
So that the force accounts for friction and gravity that you're
I
overcoming.
logged out. Stupid me.
So say it again.
So the force, when they say it like that, it accounts for the friction and gravity you're overcoming.
Yes. Yep. Exactly. Yeah.
So I kept trying to like subtract gravity and friction, and I got like a negative.
No, huh? Because look, see, we actually got a mechanical advantage less than 1 with this. So so that's going to be 0.925. Okay.
There's no
So
units for that, right?
no, for mechanical advantage there won't be, or efficiency. So that's kind of weird how we're using a ramp. What's the only possible benefit of using the ramp? Just that it makes it easier to negotiate. You know, it's like you can push at a better angle or something. But you actually lost quite a bit there. You have to push harder than you would just to pick it up directly. Okay?